into account a forecast on where LED lighting will be at in 10 years, we think we can get a pretty substantial reduction in energy consumption. So, obviously solar energy we talk a lot about is electricity, but it's not just electricity. The exciting things you can get from solar is you can get passive solar heating. You can also get renewable ambient heat, and I'll talk about that in a moment. But our air conditioners are all stigmatised as being big energy consumers, but in practice they're actually drawing energy from the air, which is an otherwise unutilised source of energy. Plus, the options in terms of solar, solar hot water, and also wind, which is indirect solar energy. So, no-brainer, insulation, one of the main, most cost-effective things you can do to improve housing energy consumption, or buildings energy consumption, including commercial buildings. We've actually been looking at raising the bar and looking at, for housing, getting insulation in the order of R6. That's R as a measure of the resistance to conduction of heat, and currently you'd be looking at R3 and 4 is what's common in housing, and certainly upper high amount in our commercial sector as well. Also looking at cool roof technology, paint. This is a really exciting area, and there's been a lot of work done in the City of Melbourne and Melbourne University trying to quantify the benefits from it. But where certainly in the commercial sector there's really enormous potential, which cuts the heat, rejects the heat from the roof and reduces the conduction of heat into the building, and it can have other benefits as well from the point of view of the urban heat island effect. Shading really critical, especially here in the subtropics and further north. We need to really reduce heat gain, solar heat gain. Glazing, double glazing. Really, it's unfortunate that it's so expensive in Australia that it's actually it's unable to grow. And we really think there's an opportunity if we have a strategy where we're actually looking at large-scale replacements of our windows with double glazing. It can substantially bring the cost down. In addition to that, low emissivity coatings and films can help to cut out additional solar heat gain. There's a really good opportunity in low E films in curtain wall glazed offices, for example, and we can't forget the benefits of curtains and pelmets. In addition, draft proofing, the fairly obvious one. Whilst we want to enable natural ventilation where possible, we also think that we're dealing with existing buildings here in this report, and that does limit the opportunities in natural ventilation. And actually, we do want to. People will be actively conditioning their houses, so we need to provide them with the opportunity to actively condition their houses efficiently, but also enable them to be able to naturally condition their houses through opening windows and doors and things like that. So yeah, again, looking at those building fabric upgrades really provides quite a substantial reduction in the residential sector. There's a huge opportunity, particularly in Melbourne, sort of in the order of 60% reduction on the previous, and also for offices and shopping centres. It's a bit smaller, but there's still something there. Okay, so back onto air conditioners. What I think really drives the message home, is that air conditioners, are able to. One air conditioner can produce the same amount of heat output as 5 gas heaters. So we don't, we're not thinking about these as efficient space coolers. They're actually great space heating devices. So you don't need. So one air conditioner can consume 1/5 of the energy consumption of a gas heater. When you're considering in Victoria that we have 70 times more heat being used in space heating in residential than cooling, that's a really substantial energy reduction we can get just from replacing our heating device. So just a quick little primer on how they work. I'm sure most people here have some understanding. But this is a hot water system, but same principles for a heat pump. What happens is we have a small amount of electricity that drives a compressor, and that compressor compresses a gas refrigerant, which basically increases its temperature. Then it's passed through a heat exchanger where it exchanges its heat to the water, and then it essentially comes back through an expansion valve and then is evaporated to the outside. So what it does is it uses latent heat of a phase change to actually extract ambient heat from the air and deliver that ambient heat to a source such as water, or in the case of your fridge, you can cool your fridge. So what happens there is, looking at here's an example of a graph of our coefficient performance, which is a measure of the amount of energy out versus energy input. This is for a Mitsubishi Heavy Industries air conditioner. What you get over a standard operation cycle is in the order of a 5 times amount of energy out that you put in. But even, often it's sort of raised that at low temperatures it doesn't perform well, but even here at -10 it's still producing at about 3.5 coefficient performance. In terms of our commercial sector, we've been looking at replacing chillers, with new water-cooled chillers that are giving us in the order of 6 to 7 coefficient performance, which is probably a doubling on what would have been in existence in the building to begin with. Replacing our gas boilers with heat pump boilers. Also looking at introducing variable air volume systems where there's constant air volume systems, variable speed drives on various pumps and fans. Variable refrigerant flow is a really interesting technology for small buildings. Provides variable heating and cooling in a building, which is basically just a glorified split system. But we're also recognising the value of natural ventilation. We're not challenging. There's an opportunity for natural ventilation that should be considered. So by doing those changes to our space conditioning, we get another substantial reduction in energy consumption. So I've just mentioned hot water. We did an extensive analysis looking at the options for hot water, including solar hot water with resistive tank heating, and compared that with a heat pump hot water system. And actually, the heat pump hot water system is actually a better option in our opinion, both because it can provide very low energy consumption heat in hot water, but it also provides very good winter performance. And for a solar wind-based electricity grid, being able to reduce demand in winter is really the key option here. And we think in the order to be able to supply the amount of energy your hot water system needs for a domestic situation, in winter maybe you only need 0.5 kilowatt to 1 kilowatt of PV. So is it worth trading off that 0.5 kilowatt to put your evacuated tubes on the roof, or if you just add extra capacity to an existing PV system, it provides you with that anyway. So for residential, sort of lumped in together for commercial, but for residential we get a 30% reduction just by putting in that heat pump system. Cooking, I'm not going to go into too much detail, I've got limited time, but induction cooktops are really the way forward. In places in Europe where they don't have dependence on gas, induction cooktops are becoming the standard. They provide the responsiveness of gas, but it's an electric cooktop, and they're substantially safer because they use a magnetic field to induce a current in the pot. So the heating element is the pot itself. So you can put your hand on the cooktop and it's not going to burn your hand. That's a really important message, substantially safer than an alternative. And for people who say you can't cook with a wok on an induction cooktop, here's an induction cooktop with a wok element. We are doing other things in the area of cooking, such as improving oven efficiencies. So that gives us a small drop there for residential again. Obviously refrigeration for domestic situations, if we can replace old underperforming fridges with the best available fridges which use green freeze refrigerants, then we can actually see a fairly significant improvement in energy consumption. But for commercial, for supermarkets is really where we think there's a major opportunity here, and it's not really been explored because people are worried about the impact on sales. But doors on display cases is really significant. Can have a significant reduction when you consider that refrigeration in a supermarket accounts for 60% of a supermarket's energy consumption. Putting doors on a display case is kind of a no-brainer. It stops you pumping cold air into the aisles, which is offset through either heating from underneath the fridge or downlights warming the customers as they walk past. It's a very inefficient system. Plus, looking at regassing with CO2 is another really substantial opportunity here. What we've been doing from a residential point of view is actually suggesting that if we adopted a sort of top runner program, which is a scheme that exists in Japan, and actually got the industry to work towards the best performing, rather than just simply cutting out the worst performing appliances in the market, we've looked at what that could do in terms of our energy consumption in homes. And you know, we think over 10 years this will actually give a good approximation for where it might go because of the pace of technology development. And just as a little indicator of that is this is the world's first organic LED TV, which came out this year, which is already surpassing an LED technology, which we've sort of been all excited about in the last couple of years. So the industry moves very quickly,